Imagine a world without stainless steel. Your kitchen knives? Rusting away. Our surgical tools saving lives in hospitals? Corroded and useless. The sleek skyscrapers lining your city's skyline? Crumbling. Sounds pretty bleak, right? Yet most of us walk past stainless steel dozens of times a day without giving it a single thought. It's in your coffee mug, your car, your phone, and even the braces some of you might be wearing right now. It's everywhere, and almost nobody knows its story. Well, today that changes. Welcome to the logic of simple things, where we peel back the curtain on the everyday objects that quietly hold our world together. Today, we're diving deep into the extraordinary journey of stainless steel, from a pile of reddish dirt in the ground to the mirror-bright surface staring back at you in your kitchen. Here's a humbling thought: the most sophisticated material in your kitchen started life as plain old dirt. Iron ore. That's the beginning of every piece of stainless steel ever made. It's found buried in the Earth's crust, rich with iron oxides, basically, iron that's already rusted. And our job is to reverse that process. To extract pure iron from iron, or we send it into one of the most dramatic environments humans have ever engineered, a blast furnace. Inside, temperatures soar around 1,700 degrees Celsius. That's about 3 times hotter than the lava flowing out of a volcano. Inside this furnace, iron ore is combined with 2 other key ingredients: coke, which is a highly purified form of carbon, not the drink, and limestone. As everything melts together, a chemical reaction takes place. The carbon from the coke hungrily bonds with the oxygen in the iron ore, pulling it away and escaping as carbon dioxide gas. What's left behind is molten iron, a glowing, flowing river of liquid metal. We call this pig iron. It's raw, impure, and honestly a little rough around the edges. So here's the million-dollar question. What separates regular steel, which rusts if you so much as breathe on it, from stainless steel, which laughs in the face of moisture and time? One word: chromium. Chromium is almost like a superhero element. The moment it's added to molten iron, something remarkable happens. It reacts with oxygen in the air to form an ultra-thin, invisible layer of chromium oxide right on the surface of the metal. You can't see it, you can't feel it, but it's there, acting as an impenetrable shield that stops rust and corrosion dead in their tracks. And the truly genius part? If you scratch stainless steel, this protective layer heals itself automatically. For steel to earn the title stainless, it needs to contain at least 10.5% chromium by weight. That number isn't arbitrary, it's the precise threshold where that protective oxide layer becomes fully effective. Go below it and you just have steel. Cross that line and you unlock something extraordinary. But chromium doesn't work alone. Depending on the grade of stainless steel being made, metallurgists also add nickel, which ramps up corrosion resistance even further and gives stainless steel that gorgeous, lustrous finish you see on premium cookware. Molybdenum, which makes the steel resistant to pitting, that nasty localized corrosion that happens in salty or chloride-rich environments. Manganese, which boosts hardness and strength. Every single element is measured with extraordinary precision. We're talking about adjustments measured in fractions of a percent, because in metallurgy, tiny changes in chemistry create massive differences in performance. Every instrument has to be exactly right. Now, even with all those alloying elements carefully added, the molten steel isn't pure yet. There are still traces of carbon and other unwanted impurities lurking in there, and carbon, in too high quantities, is actually bad for stainless steel. It weakens corrosion resistance and makes the steel harder to work with. How do you clean liquid metal? You use a process with one of the coolest names in all of manufacturing: Argon Oxygen Decarbonization, or AOD. Here's how it works. A precisely calculated mixture of argon and oxygen gases is injected directly into the molten steel through submerged lances, essentially giant metal pipes. The oxygen reacts aggressively with carbon and other impurities, converting them into gases that bubble up and escape the melt. Meanwhile, the argon acts like a babysitter, keeping the temperature controlled and, crucially, protecting the chromium from being accidentally oxidized and lost. The result? An exceptionally pure, precisely composed stainless steel melt, ready for the next transformation. Now comes one of the most visually stunning parts of the process, turning that enormous, glowing pool of liquid steel into a solid. This is done through a process called continuous casting. The molten stainless steel is poured into a water-cooled copper mold, and as it flows through, the outside begins to solidify while the inside is still liquid. It emerges from the bottom of the mold as a continuously moving ribbon of semi-solid steel, which is then cooled with water jets until it hardens completely. The result is long, thick slabs or billets of stainless steel, solid, uniform, and ready to be shaped. Continuous casting replaced the old method of pouring individual ingots, and it was a game changer. It's faster, produces more consistent quality, and generates far less waste. Once these slabs are fully cooled, they're inspected and sent on to the shaping process. But at this point, they're still rough, thick, and nowhere near the sleek material you'd recognize. The transformation isn't done. To shape those massive slabs into usable material, we apply one of the most powerful forces in manufacturing: hot rolling. The slabs are reheated to around 1,200 degrees Celsius, hot enough that the steel becomes plastic and workable but doesn't melt, and then fed through a series of enormous rollers that progressively squeeze and stretch it, reducing its thickness from many inches down to just a few millimeters, sometimes less. Hot rolling doesn't just shape the steel, it actually improves it. The intense pressure refines the internal grain structure of the metal, making it tougher and more consistent. Depending on what the steel is ultimately destined for, it can emerge from rolling as flat sheets, plates, coils, bars, or wire. But even after all this, the surface is still rough and covered in a bluish-black scale of oxidized metal. It doesn't look anything like the gleaming stainless steel we know. There's still more work to do. To clean that rough, scaled surface, the steel takes what might be the most dramatic bath of its life: an acid pickling treatment. The steel is immersed in a mixture of hydrochloric and nitric acids, which aggressively dissolve the oxide scale and any surface contaminants, stripping the surface right back to clean, fresh metal. After pickling, the steel is neutralized, rinsed, and already looking much more like the material we recognize. Before any of this steel leaves the factory, it has to run a very strict gauntlet. Quality control teams take samples at virtually every stage of production. These samples are subjected to chemical analysis to verify the exact composition, every element, down to hundredths of a percent. They undergo mechanical testing, tensile strength, hardness, and flexibility. They're examined under microscopes to check the grain structure and hunt for any microscopic defects. Only steel that passes every single test earns the right to move forward. A batch that falls short doesn't go to a customer, it goes back into the furnace. Nothing is wasted, and more importantly, nothing substandard reaches the world. This commitment to quality is part of why stainless steel is trusted in the most demanding environments humans inhabit, from the sterile precision of an operating theater to the crushing depths of the ocean. Thank you so much for watching. If you learned something today, and I hope you did, hit that like button, subscribe so you never miss any video, and drop a comment below telling me what everyday object you'd love us to explore next. Until next time, keep looking closer. The most fascinating stories are hiding in plain sight.